Welcome to Revise for Physics, the place where you revise for physics. Good evening, and in this video I'll be looking at section 5.2 from the Cambridge IGCSE Physics specification, looking at 5.2.1, the detection of radioactivity. So there's two specification points that we need to look at. It's core, so they're for everyone to understand, and they are how to demonstrate an understanding of background radiation. So you need to know what background radiation is, and you need to know how to detect alpha, beta and gamma rays. So firstly I'm going to look at background radiation here. So background radiation is radiation that we get exposed to constantly, and it's split into these two categories, natural and man-made or artificial. So what I've got here are the sections, okay, split into some of the sources that you might find, okay? And I've also got this nice little diagram here which I took from this site, which is just a fairly easy diagram to find. Just search for background radiation and it's one of the top diagrams on Google. So we've got natural background radiation, includes radiation from rocks. Now you're probably thinking, how do rocks make radiation? Well, rocks contain elements that are radioactive. Radioactivity is a random process. So when rocks containing radioactive substances have these substances break down or decay, they can emit radiation. Now that radiation might be absorbed by other rocks, leaving it completely harmless to us, or it may be that those rocks are nearby, maybe near the surface, and we can get some radiation from them. Now the main source of radiation is radon gas. Now radon gas comes from the ground. So what happens is these substances that are radioactive break down and they form radon. Okay, so uranium is the most common radioactive substance, and that breaks down into thorium, which can break down into radium, and then that breaks down into radon. You don't need to know or memorize that chain, but it's basically radon comes from uranium in the rocks. And this radon is a gas. This radon will break down, okay? But if it breaks down when it's inside your body, when you've breathed it in, then all of the energy from that radiation is absorbed by your lungs. So that will give your body a big dose of radiation. Now, other forms of radiation, natural radiation that we're exposed to, are cosmic radiation, sometimes called cosmic rays, and that just comes from space. So the sun produces most of what we receive because that's the nearest star. In addition to that, there's also food and drink. Nobody eats radioactive stuff intentionally, but carbon-14 is a radioactive isotope, and carbon-14 in its radioactive form might be found in any food. In addition to that, there's also other radioactive isotopes such as potassium, and these, if they're eaten and they give off radiation when they're still inside your body, that radiation will be absorbed by your body, and that increases the dose that we receive. In terms of man-made or artificial sources of radiation, okay, we've got the medical industry, and nuclear power and nuclear weapons. Now we don't really receive that much power from that much radiation from nuclear power and from nuclear weapons. It has fluctuated in the past. Okay, and when Chernobyl, the Ukrainian nuclear power plant, exploded in late 1986, I think it was, that released a huge amount of radiation, but that has since decreased. The environment has soaked it up, has absorbed it, and the level is constantly decreasing. And seeing as nuclear weapons aren't fired on a regular basis and aren't being tested regularly like they were in the 60s, 70s, then that is hugely reduced now. So most of our man-made radiation comes actually from the medical industry. Each time you go for an X-ray, that is a huge proportion of the annual dose of radiation that you'd be exposed to. That means that you do need to limit the amount of X-rays you have. And in the past, before people understood that X-rays were dangerous, there wasn't a limit, and that could of course pose health risks to people. Detection, that's the second point that I want to look at today, and that's a very simple basic point. All you need is a Geiger counter. A Geiger counter has two components. There's a part of the Geiger counter that detects the radiation. When radiation goes through the Geiger counter, provided it interacts with the Geiger counter, the detector will create a small electrical signal, and that electrical signal is then goes to a counter that just counts the radiation, and that gives you a measure of how much radiation has been received by the radiation detector or the Geiger counter. Okay, so those are the 2 points covered, mostly background radiation, but a little bit on the detection. So thank you for watching. I hope the video has been useful, and hopefully there'll be more in the future, so keep on coming back to the channel and learning.